Okay, so welcome to the first tutorial of this year's lessons, and today we're going to be talking about estimating. This is a very powerful skill. It's a little uncomfortable at first, popularized by the great scientist Enrico Fermi, also known sometimes as the back of the envelope calculation. So we're going to get kind of right into it with a little bit of a review. So our three units that we'll be talking about a lot in the beginning of the year are our distances, mass, and times. And if you recall, in the metric system, the lengths we're talking about are the meter, and the symbol we use for the meter is the letter M. And just so you know that typically when I'm talking about units, I'll put them in brackets like that. So M stands for meter, it's in brackets. Mass. The base unit for mass is the kilogram. Okay, so this is actually this is the only base unit that actually has the metric prefix kilo standing for 1,000. And its symbol is kilogram, kg. And then time, we have the second, and its symbol is the letter S. Okay, so nothing new there. Okay, so when we're talking about estimations, what are we trying to get? Well, really all we're trying to do is get within what's referred to as an order of magnitude, which is really just nothing more than a power of 10. Okay, so an order of magnitude of 10 to the second, the order of magnitude would be the 2. The order of magnitude for 10 to the minus 3 would be minus 3. And when we write an estimate, it can only have one significant figure. Okay, and if we want more, we're going to have to start taking measurements. So with that being said, what would be an acceptable estimate for my weight in pounds? So when I start looking through all these choices, I notice that this first choice right here, it's got 2 sig figs, so that can't be that's not an acceptable estimate. Likewise with this got 2 sig figs. Okay, here we have 3 sig figs, so that can't work. So now we're down to 4 different choices. Well, 100 pounds might be a little low, you might be thinking. And 400 pounds might be a little high, or even 800 pounds. However, if you notice that they all have the same power of 10, they're all 10 to the second. So when we're trying to get just an estimation, and 3,000 being 10 to the third, when we're just trying to get an estimation, any one of these would be an appropriate answer. Okay, now 400 and 800 pounds is very high. However, it all falls within the same power of 10. So that's what we're looking for when we estimate. So you might be thinking, well, is it a guess? What is the difference between an estimate and a guess? When we estimate, when we are just doing my weight, you are basing it compared to what you already know, your weight. And we're both human beings, so we're going to be within the same power of 10. So it's always based on something that is already known. And for the weight, you know your own weight, so therefore that's what you're basing on. Where when I say a guess, it's nothing more than just a shot in the dark. Okay, so here are so we need to know some basic information. This is what I will kind of call later on a common sense reference. So when we're talking about small lengths, we might say the millimeter. Okay, so 1 millimeter. Or we can write that as 10 to the minus 3 meters. Because the prefix milli stands for thousandth. So that's 10 to the minus 3. Long distances, we might say kilometer. Okay, or the kilometer, it stands for 1,000, so that's 1,000 meters. So when we're trying to compare kilograms based on what you already know, you're probably more familiar with pounds. So 1 kilogram is approximately 2.2 pounds. Okay, So if we want to get an idea of how many kilograms your mass of your body is, take your weight in pounds and divide it roughly by 2.2. Small mass, a gram is about the mass of a paperclip. Other things that you might want to jot down there is a centimeter. A centimeter is approximately the width of your pinky. So if you're looking at your pinky right now, it's about a centimeter. And then if you're in a room with a door, the meter is approximately the width of a door. Now, if you're comfortable with feet, okay, a meter is approximately 3 feet. Okay, a meter and a yard are very, very close to one another. So when we're trying to look for problems with this, okay, all we're looking for is if we get it within the same power of 10. So the mass of a typical adult human being, okay, roughly 150 to 250 pounds. So if I divide that by 2.2, we get something close to 100 kilograms, or 10 to the second. An adult elephant. Well, you might be thinking, elephant's roughly the weight of a car, okay, or maybe a truck, more like that. So either way, we're talking in the thousands of pounds. So divided by 2, we're still in the thousands of kilograms. So maybe 10 to the third kilograms. Now, it might be as low as 1,000 for a small adolescent elephant, okay, but it might be anywhere up to 7,000 kilograms for an adult elephant. That doesn't make a difference because all we're looking for is the same power of 10. A thickness of a dollar bill. Well, if you think of a centimeter being the width of your pinky, then you know that there's got to be many dollar bills that fit within the width of your pinky. So maybe we're talking on the order of 1 millimeter, which is equal 10 to the minus 3 meters. Time needed to get from Canandaigua Academy to New York City. Well, it's about 5-hour drive. And 5 hours, if I convert that into seconds, there's 3,600 seconds in 1 hour. Hours cancel out. And so since we're just getting a rough idea, we can just say this is 5 times about 4,000. And 5 times 4,000 is approximately 20,000 seconds, or 10 to the 4th seconds. Volume of this room. Well, the room is a rectangular prism. So if I draw that out here, and the room I'm in right now, which may be different than you, is I'm looking around and it's about 4 meters wide, about 3 meters high. Remember, 1 meter equals 3 feet. And about the depth of it is about 3 meters. So volume equals length times width times height. This is 3 times 4 times 3. 3 times 4 is 12. 12 times 3 is 36 meters cubed. And that is 10 to the first meters. So try that out for the next 2 examples. The number of dice that could fill this room and the mass of water in Canandaigua Lake. And we'll check tomorrow about what you guys all get and compare answers. All right, that's all for now. Take care. Bye-bye.